All right. Just a very brief introduction on what is EasyEDA and what's the program about today. So today I'm going to walk you through cloud-based PCB design using EasyEDA. Of course, you have other software, commercial software such as Proteus or Altium that are really expensive and costly for undergraduate or for some university that cannot afford it. Then we have some alternative. I will teach you how to translate circuit into PCB and where to make cheap PCB, right? So 5 pieces for 20 pounds. I think that's pretty cheap. All right, so don't worry, we'll go through this process, right? Okay, so this program is sponsored by the UK-China Belt and Road Initiative Program, which is, core partner by several universities. So today we have participants from Vietnam, from China, from Thailand, and from United Kingdom. All right, so then we work together with IET to organize, and IET on campus, Dr. Syed, for this program. Okay, so what are we going to learn today in our workshop? Okay, this is the outline. All right, so first you need to register, have an account with EasyEDA. Okay, never mind. After this course, you actually, I'll try to upload to YouTube so that you can get a copy of this video. All right, so probably you are not able to run it now because it's a very short workshop within an hour. So I prepared the content for an hour. All right, so you need to register first with EasyEDA. I think everyone knows how to register, is it? Then we'll draw a circuit, label the circuit, convert the circuit into what I call tracks and components. Then we'll place the components on the board, auto route it, do some design rule check or DRC. Then we insert text, logo to make your board look professional. Then we cover it with a copper layer to reduce noises. You need the ground layer. Then we convert into 2D, 3D view that will impress your lecturer or your project evaluator. Okay, then we export the bill of materials, the BOM list. Then we will generate Gerber files. Then you're ready to send it for fabrication. So you don't need to have a fabrication in your fabrication lab in your university. Just send it to China. China will make it for you, right? At a very affordable price. Okay, I'm not trying to promote China, but that is what I benefit from the so-called the world factory. All right, so this is the example that I have designed for a thermal probe, or you can call a digital thermometer with IoT facility. All right, so that is on the top is a top layer for a breakout board. Then at the bottom you see the other side, the bottom layer for that PCB. All right, this is what we are going to make today. Right, so first you need to first you need to register here. Can you see a register button? I mean, you go to Google. All right, then you key in EasyEDA, right? Then you register, okay? Register here. Okay, get an account. All right, after registration, then you click in EasyEDA Designer. Okay, that will bring you to a page. Currently, I just show you this. Later on, I will show you the demonstration how to use it. Okay, there are some tutorial in the EasyEDA documentation, so you can have a look at it. Just click around, you will come to this page. All right. So for example, okay, you have your Gmail ready, your password ready, then you sign in. Okay, sign in, you'll come to a designer dashboard that looks like this. Okay, all right. Okay, there's one thing that I'm not going to talk about today is about the PCB trace width. All right, so if you have higher current, then you need a bigger track or bigger PCB trace width. Okay, then you need to input, do some calculation. You can use the PCB trace width calculator. Okay, just key in your current, the thickness that you required for your PCB design. That's another topic that I'm not able to cover here, right? So right now we are assuming that you're running at 100 milliamp, 200 milliampere, so that's very low current. You're not running at 1 amp, 2 amp, so we are less concerned about a bigger width. Just small width, it will be good enough, 0.1, 0.5 millimeter or 0.1 millimeter, right? So you can look into this website for further information on the pad width, on the trace width. All right, so these are more detailed design, right? So my objective today is to get you started very fast, or at least guide you a little bit to have you kickstart on your project, from a messy wiring into a more organized PCB. Okay, let's get started. All right, so let me bring up the interface. Can I make this? Can I move this away? All right, so this is how, once you log in, this is how the EasyEDA dashboard or designer looks like. Is that okay for you? Right? Right, so I'm trying to see whether I can log in and log out again, then you see what happened. Okay, let's say trying to log it out. Okay, let's say I log out first. Okay.
Excuse me.
Yeah, sorry.
Yeah. We can see the PowerPoint.
You cannot, or you can?
We see the PowerPoint at the moment.
Oh, you see the PowerPoint. You didn't see my EasyEDA. Maybe I shared the wrong screen. Okay, thanks for telling me that. Okay, let me share another screen. So I thought it's automatic. So right now, can you see my EasyEDA?
Yeah, that's better. Thank you.
Thanks a lot. Thanks a lot for telling me. Okay, right. So this is how we sign in. Once you get an account, you sign in. All right. Okay. Then you come to your EasyEDA designer page. So you click in here. All right. So you come to your main dashboard for you to design. Okay. So it's very messy, isn't it? The first time when I look at this interface, I feel that it's so messy. I don't know where to start. Okay, don't worry. Okay, now on the left-hand side, there are some tools. These are important tools. I tell you the most frequently used is this, the IC symbol, and this. Okay. Then we will have the project folder. So these first three folders is the most frequently used. All right. So you need to create a new project. Okay. So you just click on new project. Okay. So you can call this training PCB. All right. Is it the same? Okay, that's okay. Okay, make sure you know where's your folder, where you keep your files. Okay, once you create a folder, then by default, there's a sheet, an empty sheet. Okay, sorry for my pronunciation, that's not very good. Okay, empty, what do you call, worksheet. Okay, that looks like this. Okay, so now we need to start inserting the, what do you call, components. So I'm going to design a breakout board. So let's go to the library. So it contains vast library. It contains the commercial library and the, what they call, the user contributed library. So there are lots of different types of components. Hopefully you're lucky, then you get what you need. All right, so I'm going to have used VMOS D1. Okay, so now Arduino Node MCU is so popular. So here we select VMOS Node and D1. VMOS. I hope the internet is working. VMOS. Don't fail. What happened? And this time, what's going on here? Okay, let me work on this one. Okay. Why it's not loading? I don't know what happened here. It's supposed to load. Okay, anyway, once you load, you see a list of components, right? What's going on here? Maybe I have two accounts. Okay, anyway, I've prepared backup plan. Okay, this is how it looks like once you load your component. You just key in and look for the component that you need. All right, so because now we use a lot of headers and female headers that it has a width, I mean the pin to pin width is 2.54 millimeter. So make sure you select the right component, right? The right component. For example, I have selected header female and header male. All right, those are the common components that we use. I don't know what happened to this. Maybe I have opened too many accounts or what. All right, anyway, it's supposed to work, but don't worry, it's supposed to work, yeah. Okay, all right, so you can look for components from this search website. I want to tell you where to look for the right components. It's either you use the user contributed or you use the LCSC provided. All right, so the difference is for the user contributed components, they give you the layout, the footprint, but they don't give you the actual component in 3D view. But if you choose components from the LCSC, it will give you these three, the symbol, the pad or the layout, and also the 3D component view like this. Right now, I don't know why it's not working. It was working half an hour ago, but maybe I need to close and open again. Anyway, okay, once you have selected your component, okay, you should, it should look like this. It look like this, okay? All right, so the, if you want to select the ground and VCC, all right, so put it here, select the VCC and put it here. Okay, to rotate the components, it's very important to learn how to rotate the component. What you need to do is to press the space bar to rotate the symbol or the components, all right? Okay, so I just simply put here. Okay, to do the wiring, so there are two important tools here. One is the drawing tools and the wiring tools. So we are going to make use of the wiring tools, which is here, the wire. Can you see the wire here? Yeah, or you can have bus bar if you have bigger, more lines to draw. Okay, just let me zoom. I scroll my mouse to zoom, okay? So just click here with a dot, then connect to the wire that you need. Okay, right now I'm not following the actual circuit, so I have a spare circuit later. All right, that's how you do connection to the circuits. All right, okay. All right, so to label the pin, let's say you want to do labeling, so escape, okay, escape to free your mouse, then click on this header here, then you label, maybe you say this is your ground. Okay, maybe you say this second pin is your, what they call the SDA, or this is your clock, SCA, SK, okay? So this is how you do your labeling on circuits. Okay, right, so you can also insert the name title file by default. So just type in, okay, what is this? All right, okay, then you want your professional looking circuit diagram like this, then you want to put in your logo. So you make use of the drawing tools here, yeah? All right, so you select an image. Okay, let's say you want to select a logo, can be any logo. Okay, let's say you insert the your university logo. Okay, then you insert it here. Okay, can you see it? Okay, or you can have the British Council logo here. Okay, so that makes the diagram look, I mean, representing your company or your university or your faculty or your department. Okay, right. So that is how you make wiring and also make connection and labeling the connectors or the components. All right. And also type in your title and company name. All right. Let's see the chat box. Any question? Not the Google Doc form. That form is for the attendance. All right, for the e-certificate. All right, so I'll stop for a while and open for question just in case I'm going too fast and you couldn't catch it. Any question regarding this wiring, the diagram, labeling, and also putting logos? Anything that you're not sure? Is that okay for you? Okay, so there are also, if there's nothing on, then I'll carry on. Okay, let's say you have been playing around, you zoom in and zoom out using your mouse roller, isn't it? So you want to go back to the default view, click fit in window. Yeah, fit in window, then you come back to here. Okay, you can also use the zoom in button and zoom out button to enlarge and reduce the size of the view on your computer screen. Okay, oh, it's a shame that I couldn't load out the components here. I don't know why load failed here. Maybe I'll try it out later. Okay, you can try it. I think it's pretty easy and straightforward. Okay, don't forget to save your file. You can save it and give it a name. Okay, maybe let's start. Okay, this is the starting. Then I save it. Okay, right. So then it will save in a folder here, right, in the start folder. Okay, right. So for example, I have the what do you call the circuit drawn completely. Okay, now how sure am I that this circuit, there's nothing wrong with the circuit or there's no connection errors? So what we can do is you can do a DRC, a design rules check, okay, that we'll do it later, yeah? All right, so now I have a complete circuit drawn, okay, with the main controller, with the female and male connectors, right? Drawn, okay. Then we need to convert schematic to PCB. Okay, so where to get the button is here. I mean, the icon is here, like a two fish button. I call it a two fish button. You can convert now. Start converting this schematic diagram into PCB. All right. Okay. So it will prompt you and ask you what is the size of your PCB. In this case, the width. Okay, the width. If 97, you have to know the width. I mean, what is your design size? Okay, to 40 height. 97 millimeter for the width and 40 millimeter for the height respectively. All right, how about the edges? What type of edges do you like? I like round rectangular, so you put it there. How many layers is your board? It's a copper layer board in millimeter unit, okay, or the radius, what's the radius of your edge? All right, so then you say apply. Okay, so now this is what you get, the board outline. Yeah. So I frequently have this problem. I mean, it duplicates, but it's okay. Okay. All right. So you start placing, I mean, dragging the components to be on the board. Okay. Okay. Put the components. Okay. If you want to rotate, press on the space button. Then bring this up here. All right. Okay, bring this up here. I remember somewhere here. Okay, then this for the OLED. For the OLED, put it there. Then this is for the extra, too many. Okay, I don't need this. Okay, you can just, if you don't need it, you just delete. Okay, I press the delete button. All right. Okay, then we rotate. I'm pressing the space button to rotate. All right. Okay, then next we turn this button here. Okay, we put this. Do we need this? Maybe we don't need this. This is an extra. Maybe I don't need. All right. Okay, then, oh, this is an extra. So there's a duplicate. Okay. All right, so you can move the components around. Okay, positioning to, I mean, the suitable position for your connection to the peripheral wiring. Maybe you have connectors. Okay, you must have a good idea where you want to put the connectors and the components. Okay, probably you want to leave some space for strain relief for your cables here. This is the USB micro USB cable connectors here. Or you want to put some logos here later. Okay, leave some space here. Or you have some component that you want to insert here with these connectors here. That's why I leave some space here. Okay, so this is how we place the components. So I finished my second point of the outline. All right, so okay, what is next? Next is to do the auto route. Okay, I hope it works because there are too many people using, so sometimes the auto route doesn't work. Okay, you can have some design rule to set. Okay, what is the spacing between the trace width or spacing of or your diameter of your width, whatever that you want to set it here. Okay, then you do run. Okay, so we are very lucky today. There are less people using the cloud, so it's able to what you call produce the routed circuits. All right, so it's done. It's 100% done with zero failure. Then you say, okay. So this is the red color represents the top layer tracks. The blue color represents the bottom layer tracks. How do you know? Okay, look here, look at this window here. Can you see the red color for top layer, the blue color for bottom layer, the yellow color for the silk layer, then the green color for the bottom silk layer. Okay, these are for the four important layers. Yeah. All right. So I'll explain the silk layer later. Silk is for the printing on your PCB after the resin or the polymer is poured onto the copper layer. All right. Okay, now let's look for the VCC. Where's the VCC? Is here, 5 volt. Is it? You can drag it around. Yeah, don't worry. It'll tell you if there's an error. Okay. So let's say you want to give a bigger wave to the VCC so that the power can go through easily. Let's say you want it to be 1 millimeter, right? Big, huge. Okay, or you can have the ground Ground, don't worry, ground, because the whole layer is going to be ground. You'll fill with ground later, so you don't have to worry about that. How about pre-vote? Make it slightly bigger. Okay, easier for troubleshoot or identification later. Maybe I give you a 0.5 or 0.5 millimeter over here on the track properties. So you can change the width on the track properties on the right hand side here, right? Okay, what else? Okay, I think I finished the auto route and I've shown you how to set the track width. Okay, let's do the DRC. We have to do design rule check. Let's go under the design tab. Okay, check DRC. This is the most important part. If you can't pass this, you cannot, produce a correct PCB. You give you the wrong. So clearance pack track, where is it? Oh, here. Can you see that? That's an error. So how do you mitigate this error? So what you need to do is move it slightly here, higher, move around here. I think, okay. All right, then you run your DRC again. Can you see my mistake here? Clearance on the pad track. Okay, design, then check DRC. Okay, pass. Now the error is 0. DRC error is 0. Oh, that's good. Okay, that's good. That's good. Okay, now we have everything clear. We have the track produced. We have done the DRC, design rule check. Okay, it's time to put some attractive logo that you feel proud. Okay, okay. So how to put logos? Okay, the earlier mistake that I made is I put on the top layer and bottom layer. I didn't realize that I need to click on the top silk layer. So silk layer is the white color printing on the resin that is laid on the copper layer. All right, so you have copper, resin, then you have your printing on the resin. All right, so the top silk layer is usually white color. Okay, so what you want to put? You want to put your university logo? So we have participants from Dongguan University. So let's click on Dongguan University logo. Okay, so you can change the threshold. Let's say you're not happy about the printing, too narrow or because of the image processing is not well done, then you can actually adjust on the corner threshold, simplified level, or color tolerance. Okay, I will tell you if I'm designing a 90 by 40 millimeter board, okay, the logo shouldn't be too large. Maybe I give it a 25, size 25 millimeter. Then we insert the logo on our board. Okay. Okay. So now I want to insert another logo at the bottom layer. So we call it bottom silk layer. Click on the bottom silk layer. You see the color changes. So now we're actually at the bottom. So go to the PCB tools again. Go click on the image button. All right. Okay. Select another logo. Okay. So which university do you want? Shall we select IET? Yeah, we select IET then. Okay, you see some words are not so clear, so maybe you can adjust a bit to make it better for the image processing. All right, okay, so you can adjust that. 134 millimeter is too large, so let's put it 20, maybe 20 millimeter. Then we do insert, then you put your logo here. Let's put another logo. Okay, then you do escape to free your mouse. Okay, let's do select another logo for ENU maybe. Yeah. Okay, then you in the size you can make it 30 millimeter. Insert here. All right. Okay. So let's say you want to put your name. You're so proud with your board. You're happy with your design. So you have spent a lot of time doing it. So double click on the text. Click on the text on the PCB tool. Bring it here. Then you can place the text there. Then you change the text. Double click on the text, then you can change the text. Let's say you want to put your name. Sebastian, I just know him. So Sebastian ENU, today is 24th January 2022. All right, so how? This is not rotated. So what you can do is press your space bar. Okay, then you can, it's too large, isn't it? So make it smaller. How? Change the property, text property to 1 millimeter. Yeah, you got it. Okay, I made the mistake on the S. Yeah, the S is a small letter S, so let's make it bigger, change it. Okay, so that was corrected. All right, okay, so now we have a beautiful PCB layout. Okay, all right, so to ground all the noise from the surrounding, to have a good grounding, we need a copper layer, a full copper layer. So where to get the full copper layer? This is the very critical part, because when I first learned this software, I didn't know how to do it. So let me show you how. So don't worry. Just click on the copper area symbol on the PCB tool. Okay, you can see that the net is ground. Then click OK. Then you can see some dotted line, red color dotted line. Just click on the boundary, I mean the outer area of this board, anywhere, yeah, as long as you covered the whole PCB, yeah, for 4 corners, then you join it back to finish off the area. So then you click on that dot and press escape. Okay, press escape. All right. So ta-da! Now you have the top layer ground laid. Okay, that's beautiful. Okay, let's go for the bottom layer. All right. So the bottom layer need to be grounded as well. So what do? So repeat the same steps. Okay, then click on another 4 corners outside the board. All right. Okay, click on 4 corners, then click escape again. You get the blue layer. That is actually the ground layer. All right. So we are done. So I finished my point number 6. All right. Okay, how much time? I have 30 more minutes. That's fine. Okay, so we have finished and successfully designed a beautiful looking PCB, like cooking. Yeah, cooking with Sun. Okay, now let's generate a nice 2D view. Let's click on the 2D button. Wow. Okay, that looks, I mean, presentable for me. Okay, how about the bottom layer? How do I visualize the bottom layer? This is top layer with all the gold color tracks if you want. All right, so then click on the canvas properties on the right hand side here. Click on the bottom layer, then you get your bottom layer. All right. Okay, how about the 3D view? How about the 3D view? Can I have a 3D view? 3D view. Okay, let's come back to this here. Let's save it. I save it. Then okay, can you see 3D here? 3D view. Okay, click on the 3D view. Then it will start generating the 3D visualization. Look, okay. So see, it even position the components. You know why? Because when you send to LCSC to fabricate this board, it will come together with the connectors, all soldered. You don't have to do it. But usually I don't do that because you have to pay extra money for that. So I will solder it myself. So I don't put, I mean, this is just for visualization. I don't send to LSCS, but I will show you where to send your board just to make the board without the connectors, okay, without the components, what I'm trying to say. Okay, do you see that this header 4 and this P3, one without the, without the connectors? Because we have, this one we have selected the LCSC library with, that's why I said this one contains the footprint and also the 3D components, but H4 was selected from another, I mean the user library, so it was without the 3D view component, right? That's the difference. All right, so if you choose this, I mean it's still fine, you just get the PCB track without the components, but of course with the components it look much better and much more beautiful, isn't it? Right, so that is how we generate the professional looking PCB. Very happy about that, isn't it? So I'm happy also because I was worried that I'm not able to do the auto route because there were so many people using it. So during busy time, it's difficult, right? So happy about that. So we need to screen capture it or print screen or anything to save it and to present, I mean, in your final year report or for your PhD thesis. Okay, so I'm sure you know how to screen print, isn't it, to get this colorful PCB. Let's go back to the board. Okay, let's come back to this board. I wanted to show you how to generate bill of materials, which is very important that we use it in the industry. So when you prepare your ISO documentation for your PCB, there must be a list of components that you use, which is called the bill of materials. Okay, where to look for the bill of materials? Come to the File tab, then you'll see Export BOM. Yeah, Export BOM, that will list down all the components, even the price. Can you see that? Assign LCSC part, right? So it's a company that provide you services. That means they'll solder for you if you send to them with all the components that we selected. That costs about 0.035 US dollar. Those are quite cheap actually. All right, so now we're finished. You can export. Can you see the bottom here? There's export BOM. So export it, click it. So these are the information will be exported, maybe 3D model, part list, contributor. Okay, so export it. let's say I save it in a folder that I call my training EasyEDA. So my board list on the 24th of January. Okay, done. Okay, let's see what is inside the BOM list. BOM. Okay, let's see the BOM list. Okay, this is what we get. Just ignore it. All right, so they will list out all the components that are used, all right, the quantity, the part number, then you have a better idea what are the total components. All right, okay, done. All right, cancel this. Okay, so now we want to generate Gerber files. Let's say there's one company called PCBway.com. There's JLPCB that you can send for the manufacturing of this PCB. So you need to generate the Gerber files. So you go to File, Generate PCB Fabrication File. So Gerber files are the files that contain all the CNC code or the G code that when they do the drilling or drilling of the holes, okay, at the designated XY position, this file will contain those kind of information. All right, so you click on that. Okay, that will generate the Gerber file. Then Gerber view, yeah, Gerber view. All right, so okay, so how much? They didn't pay me anything, so I'm not advertising for them. I'm just telling you there's a manufacturer called JLCPCB. All right, that you can send to manufacture your PCB, your ready PCB at different quantities, as low as 5 pieces. That is good for me, because in Malaysia, if we want to fabricate during the old times, we have to pay a lump sum of money, thousands and thousands to fabricate PCB. Now I just pay £20. I can get 5 pieces of PCB. That's wonderful. All right, so what is the thickness that you prefer? The standard is 1.6 for the PCB. What color do you like? Red. You like red, yellow, blue, black? Okay, you can have black color. All right, that costs how much? Are you with lead or without lead? Do you know what is ROSH compliant? ROSH compliant means it's without lead, it's safe for the environment. So usually in the industry, they want ROSH compliant so that it's lead free, it's safe for the user, right? So in this case, we use the lead, all right? So 1 ounce. So it show you the price just now, all right? Okay, it's about $4 US dollar, $4 US dollar, all right? Then you can generate your Gerber files. Okay, so you generate in a folder. Let's say you don't want to send to JLCPCB, you want to send it to other manufacturer, you can do so. So that Gerber files will contain all your silk screen information, your PCB layout, your drill hole, all right? So this is the file that you send to your foundry to make the PCB. All right, okay, what is next? Oh, finish. Okay, now you want to present the project, I mean these files in your report, you want to put it into your report so you can export in PDF. All right, so anything that you want to know, I mean the PCB design, then you want top layer, bottom layer, you can actually export it. Okay, export it to a folder, let's say PCB. Okay, then I open up this file and show you. Okay, so that contains, maybe I didn't click the top button. All right, so that will give you the file for the PCB, right? So it's not that beautiful, but I think it's better that you do the screen capture, then it gives you better representation. All right, okay, all right, finish. I'm finished. But there's something, how to order the PCB. So remember I shown you just now that generate Gerber files. Go to the PCB, then you generate the PCB Gerber files, design rule check pass. This is $4 for a starting price, $4, 4 times 5. It's very, very cheap, isn't it? So, okay, so where to order the PCB? One click order PCB. Okay, let's click on the order PCB. Okay, so if you have your debit card or credit card, then you can actually order the PCB from here. I've ordered quite many times already from this manufacturer. It's called JLCPCB. All right, so I even enjoyed the first time they give free PCB, right? All right, so these are the information. If you want it to be green color or you want it to be purple color, you see, you change the color. Let me make it smaller, then you can see. Okay, what color? Blue color, okay, or white color, or red color. Okay, what kind of color do you want? Or you can change, you want FR4 or aluminium, how many layers, but this is obviously 1, 2, 4, 6 layers only. All right, so quantity, how many quantity? Of course, more than it will be slightly more costly. All right, and all the information done. Okay, you can even order SMT assembly stencil later. That is another topic. So, okay, the PCB charges are cheap, but the what they call the courier service, DHL service is more costly than the PCB manufacturing price, which is about 17.80 cents US dollar. Crazy, isn't it? Yeah, your PCB is cheap, but your postage is very high. Okay, yeah, that's what I pay, but I think I'm willingly to pay because this is the cheapest compared to the regular manufacturer. Okay, you can change it to different courier service, right? So you can, if you want it, you're not in a urgent, then you pay cheaper courier service, SF Express Economy. That's what I use to choose, right? Okay, so depends on the urgency. So if you want it in 3 days time, then you have to pay higher price for DHL. All right. Okay, so that is where you log in, then you pay. Look at my order history. Then you get your PCB. For me, I waited for a week or 2, then I get my PCB. All right. All right, so these are some of the PCB that I have manufactured and ordered and made. Okay, that's it about the PCB fabrication. So I would like to all right, so if you have any question, you can raise up. Yeah.
Yes, if you have any question, you can ask our professor.
And anything that
Dr.
you're not clear or you want me to repeat, yeah, please, yeah, don't feel shy. So you need to make yourself relaxed to learn. All right, so to be honest, I'm not an expert in PCB design, but this is for 2-layer PCB. I think Dr. Carol will talk about a more comprehensive PCB design on multi-layers. She's a practitioner, right? So that will attract you to the next session later. Right, any question? That is the usual silent. So anything that you're not clear?
I've got one question.
Yes, Sebastian, please. Yeah.
Are there any rules on deciding which tracks go on the top layer and which tracks go on the bottom layer if you have 2 layers, or is it just?
Yeah, there are some design rules. You can actually check it out here because I didn't cover on that part. You can have a look here. Macrofab.com, picking the right trace weave, even the size, the positioning. But for simple PCB, you can have the ground lay the whole on the whole board, right? So the weave are important to cater for the current consumption. So you can have a look here, yeah, for further information. Can you see my screen? Sorry, PCB trace weave calculator. Maybe I didn't share my screen. Yeah.
No.
PCB. Yeah, the design rules. You need to go through the design rules. That I don't cover it here because my objective is to show you the tools, right? So these are the rules for the weave, for the pad weave, or separation between components that come with experience. So you don't, let's say, okay, you're designing. I encountered one problem before when I was designing the high power switching power 415 volt cyclic switching circuit, right? So I placed my OLED or my LCD display very close to the, because I wanted to make it compact. So I placed it very close to the switching relay. You know, my display go bizarre. So then we have to mitigate with some surge protector and also covering, shielding with all the wires. So that comes with experience actually, right? Thank you for the question. Where am I? Let me see the chat box. There are some questions. Does EasyEDA do simulation? Yes, but you can have a look here at their website. They do have simulation tools, but I have not explored it. Do you have ORCAD in your university? EasyEDA. They do have a simulation, but I don't go through that. Okay. I came across somewhere here, but I'm not sure where is it. Yep. Explore. Where will we find the recording for this meeting? I need some time to upload it to YouTube. Then I share it to Dr. Chan, or we have your email, then we'll email to you. Is that okay, Luis? Right. So there are a lot more information here that you can explore. Let me check for you. Online editor, but I think I'm not sure whether you need to pay for it or not. Simulator. Simulation quick starter. Yes, it's here. Yeah, you can go through it yourself. All right. So for this tutorial, I only talk about the PCB production. So there is a simulation circuit for that. But I'm not sure whether is it as powerful as the ORCAD. I'm not sure. So you have to explore. Yeah. Okay, thank you.
Can I ask, could you add components to the library? Like make custom components or imports from other libraries?
Custom-made. Are you trying to ask custom-made components?
Well, either custom-made or imported. Could you show if that's an option?
Yeah, I don't have time to show, but you can go through my YouTube channel. Yeah, I have put examples on how to custom-make the, can you see my screen? I hope you can see. I have a tutorial here, but I'm not prepared today because I've forgotten already. I've done it before, but I've recorded this in my, this is my YouTube channel. My name is Fiona Soon. Okay, he's here.
So for now, we're only seeing the PowerPoint. If you can, are you sharing something else?
It's here, YouTube, in the YouTube. Can you see it? Yeah, EasyEDA really. Linking schematic library.
We cannot, Dr. Soon, we cannot see the
sorry.
your YouTube.
The problem with Zoom is you have to share share the right screen. Okay, now can you see? Hello, can you see? Can you see my
YouTube? We can see now, yeah.
Yes, can see now.
Oh, you can see, yeah?
Yes.
How about who was asking? So don't worry. If you go to my YouTube channel, I prepare a tutorial how to design a custom-made PCB footprint. Okay, so I'm not covering here because I only have 1 hour. It's very short, so you can go to my YouTube channel and learn from here. Right. Okay, these are custom-made. This is custom-made, yeah. PCB. Yeah, you can even have your own graphic. You can see my graphic here. There's an arrow here because it was a mistake. I imported the graphic when I was trying. Yeah, so these are custom-made PCB with the custom-made layout. Yeah. Okay. So my YouTube channel is Fiona Soon. Then the title is EasyEDA Linking Schematic Library to PCB Library. So in this tutorial, I show you how to draw the schematic, then translate into the footprint, that it use the footprint. All right. Okay. David says, sorry, I was late. Usually we got lesson. Okay, it's okay. Where to join? So never mind. I'll do the recording and send to everyone. Please help to register what they call the attendance. Then we can send this YouTube this link to you. I mean this tutorial to you. Okay, here is the Google form to fill up your attendance. Then we give you an e-certificate. Okay. All right. I'm sorry that I'm not prepared for the simulation. I have not explored for using EasyEDA for simulation. Right. This is only 1 hour. So I can try it later on. Okay. Right. Okay, any more question? Before we pass over to Dr. Carol. Is Dr. Carol here?
Yes, I'm here. Yes.
Hello, Dr. Carol. I can't see you. I'm still scrolling around looking for you because there are so many people here. Let me scroll. Let's see. Can't see you. Okay, I can see you. Okay, you're on the second row. Okay, hello, Dr. Carol. How are you?
I'm all right. Fine, thank you.
Thanks for joining us and sharing with all the researchers and students. Thank you very much.
You're welcome.
Right. So, Dr. Said, I pass over the session to you.